Welcome to the tutorial for Acoustic Masterminds AcoustiTools application. This is the main screen showing the live feed of 4 modules. There is the real-time analyzer, the dB meter, the Augmented Reality spatial module, and a slot for a 4th module. You can add the Diagnostic PEQ, parametric equalizer, or the Diagnostic GEQ, graphic equalizer, both available through in-app purchase. Modules can also be accessed through clicking the center logo button. This opens the sort order screen where you can swap the position of the modules and access more modules beyond the 4 in the main tile screen. We will look at this in more detail later. AcoustiTools has been properly calibrated to give accurate results. One thing to make sure of is before you launch AcoustiTools, to first open your device's app switcher and swipe up to exit all other applications. This will allow AcoustiTools to apply the correct settings to access your device's microphone correctly. If other apps are running in the background when you launch AcoustiTools, those other apps may prevent correctly accessing the proper microphone settings. Let's start with the dB meter. The upper left of the cube shows the max peak value based on the greatest dB value heard until the reset button is pressed. The upper right of the cube displays the current rolling average sound level. Tap on the average time periods to display up to 3 simultaneously. The bottom section displays the current peak value. The bottom right of the module displays the max average RMS panel. You can also display slow, fast, or both at once. The Global Settings button accesses the Global Settings screen. The Module Settings button opens the dB meter specific settings. Here, you can turn the max average RMS panel on and off, turn on and off the dB color thresholds alert feature, customize the color thresholds for each section of the cube, max average, average, max peak, and peak, as well as select the time period desired for the 3 averages in the max average RMS panel and the average section of the cube. Let's look at the real-time analyzer. The real-time analyzer displays the live XY plot for dB level versus frequency. The red problem frequency line will automatically highlight the frequency on the RTA graph with the largest difference from surrounding frequencies. You can also highlight a specific frequency with the blue selectable frequency line. Tap on the RTA graph at the frequency you want to highlight, and the blue line will appear. Touch and drag along the graph to modify which frequency you want the blue line to highlight. To remove the blue line, touch its label above the graph. Let's look at the RTA module settings. The spectrum color option lets you choose if you want the RTA to show full spectrum color or solid blue. You can also select if you want the red problem frequency line to be on or off. Now for the Augmented Reality spatial module. In the spatial module, you can use the advanced Augmented Reality technology to see spatial acoustic information. First, let's place some tags. To place tags, tap the plus button at the lower right of the screen. Line up the speaker icon on the floor directly beneath the speaker and tap the plus button again to lock the icon to that location along the floor. Then, tilt your device up until the speaker icon is on your speaker and tap the plus button one more time to lock the speaker icon in place. We need to place tags representing our main speakers. We will tag both the left and right speakers. Tagging the speakers allows you to see the volume at the speaker's location from anywhere in your venue. Now we can label these tags as our mains to view the SPL over the audience in the volume variance overlay. To label the tags as mains, press and hold the main speaker button until the center of the reticle is over the speaker icon you are labeling. When the reticle is over a tagged speaker, the reticle will highlight by filling the center of the reticle's ring. Once the reticle highlights, release the button and the speaker is now labeled as a main speaker. This is the volume variance view. It shows the volume over the audience between the main speakers and your device. More tags can be placed throughout the venue to see the volume at those locations. AcoustiTools Delay Calc uses speaker tags to quickly calculate the delay timing needed for setting up your delay stacks. First, place 2 speaker tags, one on a main speaker and one for a delay stack on the same side of the venue. Label both speaker tags with the delay tag button using the reticle highlighting process. Once both speaker tags are labeled for the delay calculation, open the Delay Calc overlay. The Delay Calc overlay shows the distance between the tags, the time that sound will take to travel between them, and the sample delay. You can input this information into your system and then adjust the value further according to the Haas effect range for your specific venue. Let's look at the AR Spatial Analyzer module's settings. These are options that affect the module's distance and delay calculations. First, you can choose to display the distance in meters or feet. Next is the sample rate you want the Delay Calc overlay to use when calculating the sample delay between the two delay tag labeled speakers. You can choose to use 44.1 kHz, 48 kHz, 88.2 kHz, 96 kHz, 176.4 kHz, and 192 kHz. There are also two options that affect the delay time calculation. The Calculated Temperature text box allows you to type in the current temperature of your environment. You can choose to display temperature in Celsius or Fahrenheit. You can also customize the dB color thresholds. If you place a speaker tag at the wrong location, you can use the Undo arrow button in the lower right of the screen. Using the reticle highlighting process, once the Undo button is released, the tag will disappear, allowing you to replace the deleted tag with a new one. The revolutionary Diagnostic Parametric Equalizer is available through in-app purchase. This Diagnostic PEQ analyzes and diagnoses audio in real time or based off of averaging recorded samples across your listening positions to recommend corrective EQ settings to implement for tuning your audio system. To find out more, go to AcoustiCmasterminds.com. You can also click the link in the description below to watch the Diagnostic PEQ tutorial. When within the modules, you can back out of each area by double-tapping the screen. However, within the menu system, there will be a back button on the top left of the screen to use instead. From the main tile screen, click the center logo button to access more options. On this screen, you can access the in-app purchases, the global settings page, the info page, the ability to rearrange the order that the modules are displayed on the main tile screen, and in addition to tapping on a module on the main tile screen to launch it, you can also tap on a module's title here to immediately launch it without returning to the main tile screen. To rearrange, drag the modules to your desired orientation using the double-line bars to the right, up or down to the slot you desire. Scroll down to the Storage section to access additional modules. The revolutionary Diagnostic GEQ graphic equalizer is available through in-app purchase. The Diagnostic GEQ analyzes and diagnoses audio in real time or based off of averaging recorded samples across your listening positions to recommend corrective EQ settings to implement for tuning your audio system. To watch the Diagnostic GEQ tutorial, go to AcousticMasterminds.com or click the link in the description below. Let's take a look at the global settings. First is spectral weighting. You can choose between flat, A, B, and C weightings. Select either SPL or dBFS values to be displayed. If you want to see the digital value from 0 that the device is receiving, select dBFS. Otherwise, keep it on SPL to know how loud your environment is. Next are the averaging options. This scroll box allows you to select an averaging setting for the RTA, PEQ, GEQ, and the AR Spatial Analyzer modules. You can choose between none, 2, 4, 8, or 16 samples, 125 milliseconds, fast, 1 second, slow, 2 to 10 seconds, or 1 minute. The block size will default to 4096. This value is determining how large of a buffer is allowed to build up before being processed. The larger the buffer, the more accurate the values will be. However, the larger the buffer, the more the device has to work. If you experience trouble processing on your device, try decreasing the block size. If you want more detail, increase the block size. An additional feature in the global settings page is the microphone calibration trim. AcoustiTools is calibrated for iPhones and iPads' internal microphones using pink noise. AcoustiTools should work without any microphone trim adjustments. However, the trim setting is included in case your particular device has deviated too far from the expected tolerance. You can also apply a separate calibration trim for an external microphone. When an external microphone is recognized, the settings label will change from internal to external. Let's take a quick look at the info screen. Here there is a button to access the in-app tours page, a button to take you to the user guide and tutorial videos on our website, a button to register your copy of AcoustiTools to receive important updates and announcements through email, a button to take you to our website, a button to email us, and a button to rate AcoustiTools on the App Store. This is the Tours page. Here you can launch a modules tour. Thank you for watching the tutorial video for AcoustiTools. For more information, go to AcousticMasterminds.com.